Welcome to this explainer. Today, we're totally cracking open the core hardware infrastructure of data networks. If you've ever stared at a stack of blinking telecom boxes and wondered what actually does what, you are in the exact right place. We're going to swap out all that dense textbook jargon for practical, everyday analogies that make these systems incredibly easy to understand.
But hey, before we really get into it, let me ask you about a classic, incredibly frustrating scenario. Have you ever plugged in an Ethernet cable, seen that little green connection light turn on, but still had absolutely zero internet access? Right? It's something that totally confuses customers and honestly even junior technicians every single day. Well, today we're going to use that exact frustration to reverse engineer how networks operate. By the end of this, you'll know exactly why a connected cable doesn't always mean you're online.
So here's our game plan for today's micro to macro journey. 1. Inside the telecom highway. 2. Routers and the gateway. 3. The three core terms. And 4. Troubleshooting using analogies. Let's just dive right in.
Starting off with Section 1, inside the telecom highway. Our very first core piece of hardware is the switch. Now, from the outside, a switch just looks like a metal box with a bunch of ports. But functionally, you should think of it like a giant data multi-plug adapter. Say you have 5 computers in an office that need to share files or talk to a local printer. You plug them all into a switch using Ethernet cables. But here is the absolutely crucial thing to remember. A switch only handles local traffic. It talks to devices using their physical hardware footprints, which we call MAC addresses. It has absolutely no idea how to connect to the outside internet. None.
To make this super concrete, imagine your local network is an apartment building. In that scenario, you should think of the switch purely as the hallway connecting the apartments together. It lets the residents, or your devices, visit each other, but it doesn't actually get them out of the building.
Which brings us to Section 2, routers and the gateway. Because, think about it, if a switch keeps us locked inside the room, how do we get out? Well, that's exactly where the router comes in. A router is exactly what it sounds like. It routes traffic. It connects different networks together. So while a switch connects devices inside a single room, a router connects that entire room to the outside world. It looks at the IP address of a data packet and essentially decides the absolute best path for it to reach its destination. In the telecom world, the home router, which you'll often hear called the CPE, or customer premises equipment, is that essential bridge connecting your private home network to the provider's vast public network.
And attached to that router is a super important technical setting called the gateway, or default gateway. Simply put, a gateway is the exit point. It's the way out. To complete our apartment analogy, if the switch is the hallway connecting the rooms, the router is the physical front door of the entire building, and the gateway is the specific designated location of that exit door that the devices actually use to leave.
So look at the stark dichotomy here. It's really day and night. A switch handles local traffic, relies on MAC addresses, and keeps data inside the room. A router, on the other hand, handles external traffic, uses IP addresses, and moves data outside the room. Truly understanding this fundamental difference, it clears up a massive amount of consumer confusion.
Okay, let's put this into practice with an instant diagnostic shortcut. This is great for field technicians facing a real trouble ticket. Imagine a customer calls in and says, "Hey, I can print files to my local office printer perfectly fine, but I literally cannot open Google or any other website."
Here is the brilliant deduction you can make in seconds. Because that printer works, you instantly know local traffic is moving. Therefore, the switch is working perfectly. By separating those local and external traffic concepts in your mind, you immediately know the issue must be with the router, or maybe a wrong gateway configuration. The problem is exclusively at the exit door. Boom! Troubleshooting time cut in half.
All right, moving to Section 3, the 3 core terms. To really wrap our heads around this system, we've got to define how these devices are identified and grouped. First up, the IP address. This is a unique digital identity assigned to every single device, kind of like a smartphone's phone number. An internet server needs this exact address, say 192.168.1.5, to actually send a web page to your laptop. Next is the network. This is simply a group of connected hosts, computers, switches, routers that share resources within a specific boundary. And finally, the internet. People use the word all the time, but it literally stands for interconnected networks. It's a massive worldwide public network made of millions of smaller networks linked together.
Which takes us to Section 4, troubleshooting using analogies.
Let's be real, abstract terms like IP addresses and interconnected networks can be a little dry and tough to retain. So let's map them to the physical world using a postal analogy. Your IP address, that is just your unique mailbox number. Your network, that's your neighborhood street, where you can easily walk over and talk to your neighbors. And the internet, that is the massive international highway system connecting your little neighborhood to every other city and country in the world.
So let's put it all together and review the complete micro to macro journey your data takes when you just try to open a website. Step 1. The data leaves your device and hits the switch, basically traveling down the local hallway. Step 2. It reaches the router and its assigned gateway, acting as the front door of the building. And Step 3. It exits onto the internet, cruising down the international highway to retrieve that specific web page.
And you know, this fundamental difference perfectly explains a wildly common scenario in the field. Customers will call support in a panic, saying, "My network is down." But based on everything we've just covered, we know what they actually mean is, "I cannot access the internet." There is a massive structural difference between a localized internal issue, a problem on the street, and a cut-off external link, a roadblock on the highway.
So, the golden rule for technicians and troubleshooters? Always clarify and test the zones. Can the devices talk to each other locally? If yes, the local network is totally fine. Is the connection to the outside world cut off? Okay, then the internet link is down. Actively separating these two zones is the absolute defining trait of an expert troubleshooter.
I'll leave you with this final thought. The next time you're staring at a connected cable with a green light but absolutely no service, don't just ask why it's broken. Ask yourself, are you testing the local street right now, or are you trying to drive on the international highway? Knowing the difference truly changes everything. Thanks so much for joining me on this explainer, and keep exploring.